Welcome to my channel, A Woman in Physics. Today I want to begin with a confession. I'm a fan of Doctor Who, both of the old series and the new ones. And I have to admit, I fell in love with the Ninth Doctor. I still remember this scene where he first got me. It was when he explained to his companion for the first time basically who he was. And he mentioned that he can feel the turn of the Earth. And I was like, ooh, that would be cool, because we know the Earth is turning, we just can't feel it, right? So basically, when you're standing at the equator, you are moving at a speed of 1,670 kilometers per hour in a rotational motion around the center of the Earth, but you can feel it. And these 1,670 kilometers per hour are roughly 1,000 miles per hour, or if we are recalculating it, it's more than 460 meters every second. So each time you take a breath or you're saying 21, which is roughly 1 second, you have moved more than 460 meters, but you can feel it. And the question is, why? Why can't we feel it? Because when we're sitting, for example, on a merry-go-round and it goes at a much lesser speed, we can feel the motion. And even if we are going by car, for example, if you are going along a German Autobahn, you can go somewhere between 120 and 200 kilometers per hour. At some sections of the Autobahn, nobody cares how fast you go. You can see that you're moving, and you can even estimate your velocity because you can see the landscape around you. But when we're standing here on the Earth, of course, we're not the only ones that are moving. Everything around us is also moving. The whole landscape, the houses around us, the trees around us, everything. So we basically, in the first step, do not have any focal points around us that are not moving. The second thing is, it's not just everything on the Earth that is moving, but our atmosphere is moving as well. And I suppose it makes sense, because if it were just the Earth moving at such a high speed of 1,670 kilometers per hour and the atmosphere would be standing still, we would be in real trouble, because such gushing winds would be blowing by and we couldn't hold on to anything. So the second point is, yes, we're not the only ones moving. The landscape around us is moving and the atmosphere around us is moving. So everything's in motion. But you may be curious why you can feel it on a merry-go-round and not on Earth. Because on a merry-go-round, when you're sitting there and it moves at a higher speed, you can feel this force dragging you to the outside. How is that? Why can't we feel it here on Earth? Well, let's make a quick calculation in order to understand what's going on here. So in order to get a bit of a better understanding of why we cannot feel the centrifugal forces that are dragging us away from Earth, we have to make ourselves understand that we're basically standing on the surface of the Earth. And there are two forces. On one hand, we do have the gravitational force G that's pulling us to the center of the Earth. And on the other hand, we have the centrifugal force F that is directed in the opposite direction, dragging us away from Earth. And the question is, how strong are these two, especially in correlation with one another? The gravitational force is relatively easy to calculate. G is only the product of your mass m and the constant g. And g basically describes the little g, the acceleration that any object has in the gravitational field of Earth anywhere close to the surface of the Earth. And we know that g is 9.81 meter per square second. It's considered to be a constant, even though Of course, it depends on your location, particularly when you go hiking high up into the mountains. It's different than when you're somewhere in, say, New York or Paris, in anywhere close to the level of the oceans. And if we assume a person with a mass of 65 kilogram is standing at the equator, we can calculate the gravitational force G, and G is roughly 638 Newton. Okay, if this is quite a lot or not, actually now depends, of course, on how large the centrifugal force is. And F is slightly more complicated to calculate again. F depends on the mass of the person, but in addition, it also depends on the velocity of the centrifugal motion of the rotation and the radius around the center around which we rotate. So this is nothing new, because as I mentioned earlier, we know the velocity when we're standing at the equator with which we are moving, and this velocity is 1670 kilometers per hour, or if we are going down, to the standard units, wanting to recalculate it in terms of meter per second, we're getting 464 meter per second to be precise. So this is still the velocity. And we still need the radius of the Earth, and the radius of the Earth is 6,370 kilometers. And again, of course, we can recalculate it in terms of meter in order to put it right into our equation. So this is 6,370,000 meter. Now we have everything. We have the radius, the velocity, the mass. Let's put everything into our equation, and we are getting a centrifugal force of 2.2 Newton, which is quite astonishing, because if we compare this value with the nearly 640 Newton that we got earlier, we can see that the gravitational force pulling us towards the center of the Earth is basically 300 times larger than the centrifugal force dragging us away. So we really cannot feel it. Hence, all things considered, we cannot feel the motion of the Earth, since the gravitational force always outweighs the centrifugal force. Hence, in the first approximation, we can assume us being here on Earth, like I said, in the first approximation, of course, only as an inertial frame of reference, as it is called in physics. Which also means, no, we cannot see us moving, since everything around us is moving with us. And as a last fact, to give you something to think about, if you thought these 1670 kilometers per hour is pretty large, then yes, it is, of course. And still we cannot feel it, but at the same time we are not just, on the Earth turning around its center. At the same time, our whole planet is hurtling around the sun at a much higher speed of 107,000 kilometers per hour. And with this final thought, I will leave you for today. Thanks for watching and see you soon. Bye!